Hey everybody, we are back for lesson 10, and this is kind of like part 2. So the previous video that has the lesson 9 and 10 templates, that's like the concept development that is from the teacher's edition, and it provides a lot of opportunity to practice. It's on the previous pages in your book, and basically what we're doing is we're talking about these number patterns with the X and Y coordinates and what types of lines are created from the number patterns. Like, are they parallel, or do the lines get steeper, and what makes that happen? And so we noticed in the previous videos that when you multiply for the rule, then you get these steeper lines, whereas if you add with the rule 2 more or 5 more, you get these parallel lines. Then we also did another one that had, and it comes after, if you have the X and Y that are equal, then you have a line that goes right through the center. And if you have a division problem for your rule, like, or subtraction would be below the midway point, but division would then give you a line that's below the midpoint but flatter, and not parallel but flatter, in the same way that the multiplying makes it steeper, dividing makes it flatter. And so that is kind of in a nutshell what those other ones are, but that previous video gives you the opportunity to do the practice that you really need before you start lesson 10. So I highly recommend you go watch that video. And if you click to subscribe, you will be notified when I make a new video, and then you can come back and watch them when you're ready. So we're in lesson 10 today, and we're going to use this coordinate plane to complete the following tasks. Line P represents the rule that X and Y are equal. So X is equal to Y on this line here. And you can kind of prove it if you look at your number lines, recognize that they're counting by halves. Okay. Make a little note for yourself. And then notice that, yes, 1/2, 1/2, 1, 1. I usually use the whole numbers because it's just easier. 2, 2, 3, 3. Find those points and see that that's how the line is made. You need to construct a line, line D, that is parallel to line P and contains this point. Now, they haven't given us any other points, so you have to make the line. And I've seen some kids' lines, and they're like, oh, I'll just go like this. No, you need to use a straight edge because it matters. So let's figure out what the ordered pair is for point D so that I can figure out what the rule might be, and then I can make more. So this is 2 for X and 4 for Y. Okay, now 2, 4 is point D. Now if you want to go exactly in the right place, notice that above line P I could go 1, 2, 3, 4. Okay, so if I go from this point, I could go 1, 2, 3, 4, and I could put a point here. I can go way up the line, but I would go off my grid, so I don't want to do that. So I'm going to go down the line, and I'll go 1, 2, 3, 4. Now I have 3 points in a row, and I can see that they're parallel, so I can connect these points with a line. And again, I want to make sure I'm precise, so it should go exactly through the corners of all these other boxes. Okay, and so now we're going to name 3 coordinate pairs on line D. So where did we put these points? I only have 2 additional. We can make another one. So where do we put them? Well, I have 1.5 and 3.5. And over here on this half, we have 2.5 here and 4.5. Now you may have put points somewhere else. If you have it up here, you have to check what the address is, and the address would be the location, first using your X value, then using your Y value, and it always does that. X is first, then Y. That's how you write ordered pairs. Okay. If you want to use whole numbers, because it's less confusing, then you can have 3 and 5. Put another point there. And now what you want to do is you want to look at what the pattern is. We're going to look for what is happening over and over and over between the x and the y. Remember, the x and the y, they have a relationship to each other. How are they related? Well, if you look at x here and the y here, 1.5 to 3.5, that would be an addition problem, and we're adding 2. So if you skip up by 2, you get this one. And if you skip up by 2, you get this one. And if you skip up by 2, you get this one. And so the rule for this line would be to take whatever x is, add 2 to it, and you'll get y. And that's your rule, okay? So I could keep going. I could identify any point on this line, even out here to infinity and beyond on this line. And that would be, if I follow this rule, it would still be on line D, okay? Now we're going to do the same thing with point E. Construct a line, E, that is parallel to line P and contains this point. So from P, we're going to go down 1, 2. Okay, I'm going to use this again. I'm going to go down 2. I can use this one and go down 2. I can go down over here. Remember how much those whole numbers are helpful? Down 2. Find a whole number. Go use this line and go down to 1, 2. Look at all these points I have. They are parallel to P, okay? And we're going to construct it and draw. Be precise. And this is line D, this is line E. And we're going to name 3 points on it. So if I use this point, remember your x is first, so I've got 5 here and 4 here. On this one, I have 4.5 and 3.5. We used a whole number down here. It was 3 and 2. So what do you notice? What is the relationship? What's the connection between the x and the y? Well, you might notice that y is actually lower. By how much? Well, by a full subtraction of 1. X minus 1 equals y. X minus 1 equals y. X minus 1 equals y. So the rule, x minus 1 equals y. Y is 1 less than x. That's also, that works too. So I like to see the numbers with the x and y, but you can write it out like this, okay? Now, compare and contrast lines D and E in terms of their relationship to line P. Okay, so first of all, they are all parallel. So write that down. Okay, they're all parallel, so they're all going the same direction. They will never, never cross. But line D is above P on the graph, or on the grid. Okay, this is a coordinate grid or a coordinate plane. And line E is below P on the grid or the plane. Okay, so one is above it and one is below it. And then notice that one has an addition and one has a subtraction. So today's objective with comparing the lines and the patterns generated by addition rules and multiplicative rules, we're also paying attention to the subtraction rules at the bottom. And that is showing you what happens when we take something away. So addition and subtraction give you lines that are parallel, okay, but addition puts it above and subtraction puts it below. Now, the last one, number 2, write a rule for a fourth line that would be parallel to those above and would contain the point 3.5, 6. So I need to find where 3.5, 6 would be. 3.5 is here, but 6 is way up here at the very tippy top. So I need a line that's parallel and that's going to be all the way up here. So again, diagonal by 1. I can put a whole bunch of dots in that are right up here, okay? And this would give me a line. It doesn't say we have to create the line. We just have to write the rule for the line. So what would be the rule? So let's, and then we have to explain how we know. So let's look at the points that we used, okay? So if I've got, if I haven't even looked over here yet. If I have this on 3 1/2, 6, I want to find the relationship between my x and y. So what is the difference between this? And then compare it to my other points that I've made. So using whole numbers and half numbers, because you can also look and see the difference. So if I have 2 1/2 and 5 for my xy, or if I have 2 and 4 1/2, and now I compare that to my 3 1/2 and 6, what is happening between the x and the y values? So I can see that my y's are bigger, but by how much? Okay, so what's the difference between 3 1/2 and 6? The difference between 4 and 6 is 2. So it's more than that because it goes down a half. So it looks like it's 2 1/2. The difference between 2 and 4 1/2, there's my 2 plus the half. So that's 2 1/2. Confirm it again. 2 plus 2 would be 4 plus the half. Sorry, maybe I made a mistake there. Oh no, it's just doubled. 2 1/2 plus 2 1/2 is 5. So it's 2 1/2, so x plus 2 1/2 equals y. Okay, and hopefully that's not going to be on the video. A little update. No, don't update now. Good heavens. So if I have for my x and y, I'm looking for the relationship so that I can complete this line. And with consistent points, that will be parallel to the line that they previous gave me. Actually, the line that they gave me and the lines that I made. And remember, if it's up above the midpoint, it means we added. And so here I have my addition problem, and so that makes sense. So x plus 2 1/2 equals y. Okay, now, the quick explanation that you can write there is, first you want to look at the points you plot, or the points you plotted. Then you have to think about the x and y values and how they're related. So think about how x and y are related, and then solve the connection. It's all about the relationship. Okay, and so you want to solve the connection. So that's your explanation on how to write or draw the parallel line. Turn the page. Now we have a new plane, and this time we have different rules. So line P represents the rule that x and y are equal. P, again, right through that origin right there. Okay, x equals y. Construct a line V that contains the origin 0, 0 and point V. I have 2 points, so I can go ahead and draw my line. If I have 2 points, that's all I really need to make a line. Okay, so now I need to name 3 points on line V. So notice that when I make this line, I have points that aren't necessarily crossing at an exact corner. So my suggestion is look for the corner crossing points to make it easier for you. That's probably a little crooked, but look for the exact corner points. We'll talk about the midpoints when we get down here. Okay, so we're going to name 3 other points, not V, but 3 other points on line V. So go out here, look at what we're counting by. 1, 2, 3, 4, 5. We're counting by ones. And then label these points. So I have 3 and 6. I have 4 and 8. I have 5 and 10. Now, what would you say is the rule for line V? What do you notice? Remember, it's about the relationship between X and Y. Okay, so 3 to 6. Am I just adding 3? No, because 4 plus 3 would be 7. So that's not the rule. So if you multiply times 2, that seems to fit the rule. X times 2 equals Y. Don't put an X for multiplication because it's confusing when you have X as a variable. Okay, so X times 2 equals Y because all the Y values are twice as much as the X values. Now we're going to construct a line W, that contains the origin, 0, 0, and point W. So I have my 2 points. And I'm going to try to be precise. And now I have line W. Okay, so it should look like this. It should be evenly matched on both sides of line P. Name 3 points on line W. Again, look for where we have an exact crossing. Okay, 5, 6, 7, 8. We don't want to use W, but you can use something out here. This is going to be a 10 and a 5. Use this one down here, 4 and 2. It's easier on the whole numbers, but you can certainly use the halves if you wanted to. If you came up with a crisscrossing point like so, what about that? So what point is that? That's 5 for X, and it's 2.5 for Y right here. There's nothing labeled on the number line. It doesn't mean the numbers don't exist. It just means it's not written. Okay, so 3 points on line W. If you use the whole numbers, it's going to be 4, 2. And then, we used 8 and 4. And then 10 and 5. Get them in the right order. Remember, it's X first, then Y always. Okay, I'm going to do a 4th point, and I'm going to use this one, 5 and 2.5. Because I can, and I just want to show you that that is the proper value for the Y based on what my connection is. So what is my connection between these two? Is it minus 2? No, because if it was X minus 2, then I'd have 6 here. So Y seems to be half of what X is. So you can have X divided by 2 equals Y, or you could say Y is half of X. That would also work. Okay, and now we're going to compare and contrast lines V and W, in terms of their relationship to line P. Now, are they parallel? No. Are they perpendicular? No. So those are 2 words I'm not going to use to describe. But I would say that line V is above P and is steeper. Okay, like the steepness of a cliff is steeper than P. Line W is below P and is flatter. Okay, it's still higher than the x-axis, which is here, but it is definitely below P, and it is not as steep as P. Okay, so that is one way you can compare those. They are also, they seem to be equally distanced from P. They are equally distant from P. And so what's our rule here for line V? It was times 2. And what's our rule for line W? It was divide by 2. So notice if I'm times 2 here and I divide by 2 here, it's equally distanced from that midpoint. Okay? Now what patterns do you see in lines that are generated by multiplication rules? Multiplication rules create steeper lines. Okay, they're not parallel to the x and y that would be equal. They're not parallel. It makes a steeper line when you multiply. So with that in mind, circle the rules that generate lines that are parallel to each other. Well, it's not going to be multiplying, because we know that from the template practice that we did previously, that when you have parallel lines, it's because you are either adding or subtracting. Okay, so we're going to circle the rules that would be parallel to x. Adding will give us lines that are parallel, but multiplying will not. That would create a steeper line. X plus whatever, even if it's a half, that'll still work, but times will not. So that is lesson 10. I hope you guys understand about these patterns that are created by addition rules and multiplication rules. That's a fancy word, multiplicative rules. But come back for the next one. We'll do lesson 11 on the next video. Bye.